Hello, welcome back to BSLIVE. In this episode, I'll be testing out this Obsidian and try to install something called Copilot. So it's like an AI that can be run locally using LocalAI, but let's see how it goes. So this is Obsidian. It's a note-taking app. It's quite powerful. Let's say I want to learn about Blender Python, and we have internet, of course. We can always Google search about Blender Python, but I want to use AI to talk about it. So let's open up a setting in the Obsidian, and we're gonna be using community plugins, and we're gonna search for Copilot by Logan Young. So I'm just gonna install this. We can read the documentations, how to install it properly. There's of course documentations on how you can install local models, local AI. But let's see how it goes. Okay, we have the plugins installed, version 2.4.3. We can turn it on. Okay, API key is not provided. That's okay. Okay, we can check the Copilot. We can find out about OpenAI API key, but I will be using local AI, and let's see if this is going to be working or not. And I'm gonna paste my local AI name. This is something that I already installed earlier. So under models, I think this is the name of the model. Paste it here, and community plugins, turn this off, turn this on again. Okay, anyhow, let's try using local AI. Test. Hello. Let's see if I have this running already. Warp. Okay. I'm trying to run local AI and see if this is running. Hello. I have a feeling I will just use the chat GPT. So under settings, Copilot setting, Obsidian Copilot. I'll just Copilot 2, create secret key, copy, paste it here. Reload. So I believe we should have the chat running now. Test. Okay. What is Blender Python? So we have the answer. Blender Python refers to a programming language Python integrated within the Blender software, and so on and so on. Now under Obsidian, now we have like kind of like live nodes that we can test it. So yeah, let's try. Okay, copy this. Just like if you're studying and you have an AI that's helping you. What is Blender Python. So that's the title of the notes. We have the answers here. Okay, let's create a new notes. Give me 10 most useful Blender Python to start with. 10 useful. We can say 10 useful or 10 simple Blender Python. So we probably already know some of this. Create a cube, apply material. So let's try this. The code cannot be copied, but you can just select this part. So I think we have Blender already open. We can go to scripting or just pull this under text editor, create new. So this is for our Python code. Delete everything, run the code. We have cube. Cool. The next one, create, apply material to selected object. Okay, material name not found. Okay, we probably don't have material yet, so yeah, we can call this blah, give it a red color, material name blah. Let's say we have Suzanne. Run this. Now Suzanne should have red color. Okay, so we select this, run the script. Based on the selected objects, the first one actually is gonna give it a color. So if we select 3, 4 objects, run it, it's only the last objects gonna get the color. Okay. Apply material to the selected object. Set object locations. Okay. Create a sphere, create camera, we know, render image, yeah, and so on and so on. Okay, this is useful, it's basic, but we can copy this. Basic BPY. Okay, so we got this kind of clean nodes inside Obsidian, so we can continue. Let's try. Okay, give me example Blender Python to generate grid of cubes in 2 by 4 by 7. Once again, the AI, I think this is the OpenAI kind of doing the work for us. We can also use LocalAI. LocalAI needs some setup in order for it to work. But let's see. Let's try this. Copy paste. Run it. Okay, we have grid 2 by 4 by 7. Okay, cool. How about I want to give random material colors to selected cubes. Again, so we have all this script. Of course, in order for you to actually learn something, you read this Blender Python and then, okay, kind of look at it, and then, okay, you understand what's going on. You can make changes, for example, make it 5 by 4 by 2 by 3, whatever, and yeah, we get a new grid. This one, assign random material colors to the cube in the grid. Okay, look at the difference in the code. Now we actually have functions to create random materials supplied with this script, and then for each one of the cube, give it random color. Let's make this 5 by 5 by 4, for example. Cube size, keep it like that. Run the code. Oh, syntax error. Okay, this should be import BPY. Now we have base color. Okay, with random, where did it assign the random color actually? In this case, we get pink color. But of course, in this case, they all have a material called random materials. In this case, we can really just use this trick. Give it a random color. I know it's probably kind of cheating, but usually in order to make random color, you do it this way, or for each object, you have like a random colored object, and then so the hue, the material should look at into the object's color, object info color. But in this case, doesn't really matter. Let's say we want to create something else. Grid of cubes with random color material. Give me BPY that generates cylinder with random size stack. Give me BPY. So this is Blender Python script that generates cylinders with random size and stack. Okay, let's see how this one goes. So I'm I'm really fast at the moment, you know, like just to show you the process. But anyhow, it's just like random stack of cylinder. We can make it perhaps 30. Right? We can do things very, very quickly this way. But in order for you to learn anything, you need to slow down and then, you know, look at the script and then try to rewrite the script yourself. But this is probably it's gonna be in my books that I'm probably never gonna finish. But yeah, you get the idea. It's just like a way you can learn scripting inside Blender with AI. You know, it's powerful. It's really powerful actually. And okay, this one, stack of cylinder. In just few minutes, we have kind of like some kind of contents, right? We are using AI to learn a bit about Blender Python, and you can throw all kind of exercise that you can think of, you know, any questions, see if it can answer it. Okay, with the cylinder stacks, can you make it so that each bounding box of cylinder is touching each other? You know, we want like a stack cylinder, but each of the cylinders should be touching. Okay, each bounding box. Okay, I think it understands what we are talking about. This is the one before. Syntax error. Okay, once again, import BPY. Okay, now we have a better looking stack of cylinder with different size. Okay, they are all stacked properly. Can have 25. Remember this example using geometry nodes, but this is how you can do it using Blender Python. You know, yeah, you can probably create a grid of the random cylinder. Okay, let's say I want the script using the script above. I want to have random numbers of stack of cylinders in a grid of X and Y unit. Okay, this is now a little bit more complex. We should have saved this one. Stack of cylinder. This is the one with bounding box. And this is the last example. Maybe it's a good idea to save this. Text, new, run this. Okay. You're probably not exactly correct in this case. Let's make it 12 by 8, for example. Okay. Test. Probably I'm gonna come back to GPT 3.5. Give me a Blender Python that generates a grid of X and Y unit where each grid is a stack of cylinder of random size and stack height. Make sure the cylinder's bounding box is touching. I think I should have simplified this a little bit. Let's see if this is working. I think our question might be a little bit unclear. Okay, not bad actually. It's actually doing its job. Grid. Okay, this one actually work. So definitely want to save this. Save. These nodes actually, if once we have like a bunch of nodes here, we can actually switch from conversations into active node. And this is the feature of Copilot in Obsidian. So we have these nodes and then we have AI, and the AI can actually learn our nodes and then we can query the nodes. It's still kind of experimental, but yeah, I'm just testing this today. But it's powerful, and we can save the whole nodes. The whole conversations can be saved as a chat. See, Copilot conversations. So this is pretty powerful. So once again, let's test this. Grid unit, let's make it 10 by 8. So we have 80. Minimum, maximum radius. And grid unit size, okay. Number of cylinder. 20, or actually 5 to 25, for example. Run this. So we have gonna have like 80 stack of cylinder, and each cylinder should generate, yeah, okay. It's kind of like the procedural cylinder stacks, but except that this is running it using script, right? So yeah, I'm pretty happy with this. Even though this can be more efficient. I don't know whether you want to use AI and render scripting or actually procedurally generate stack of cylinder and then repeat it. Probably more efficient using geometry nodes, because with this one you end up with thousands of cylinder, right? You're supposed to instance it, but yeah, this is what I got so far. Stack of cylinder, grid of cubes, the usual stuff. Make random colored cube if that's what you want, but the idea is to have an AI that's kind of there. I wish this is kind of like just inside Blender, but for now I still think the AI inside Obsidian nodes is really cool, because you can save the nodes, save this into your cloud, iCloud, and then you can read these nodes while you are away from the computer. You can make modifications. Yeah, and then you're learning. And let's say, okay, give me 25 challenges that I can solve using Blender Python. So you are asking the AI to give 25 challenges that you can, solve with Blender Python. Build procedural terrain using noise, particle system, develop script to animate a character rig, cityscape, which one is okay, procedural tree, grid of sphere with random sizes and color. This one you can run. The first one should be possible. You can try doing it yourself or just AI. Give me solution for, give me BPY that generate a grid of sphere with random sizes and colors, the basic one. Although you should you should try to do this yourself. This one, random sphere. Okay, let's save this. Go into scripting, new, paste, run this. Interesting, this one doesn't actually generate sphere of random sizes. Set object has no attribute data. Line number 26. Okay. Fix the code. Just create a grid of sphere with random sizes and give it material name random. Okay, select the script. Okay, that's better. We have material called random, but this one is not using nodes. Just enable nodes and then give it, once again, give it a hue. Random objects plug into the hue, color, Okay. Now we can create whatever grid of sphere. Okay, this time it's actually, okay, it's recreating another material called random math. But you know the drill. Select all, Command L, link materials. We have a grid of random sphere. So random sphere. Okay, there are certainly many other challenges here. Script to create procedural fractal landscapes. Some of them are really easier, you know, much easier using geometry nodes. Automatically unwrap UV for given mesh, flocking behavior, flag waving. Maybe the useful the useful one is like if you want to modify geometry nodes modifier. So if you have like geometry nodes applied to an object and you want to randomize the custom variables or parameters of the geometry nodes, that's also probably something that I can try on the next video. This one. Anyways, so sphere, random sphere radius in a grid. So all these nodes gonna grow. Pretty soon I'll have like 100 examples of random Python, for example. Yeah, I just need to think some creative ideas. Okay, maybe using BPY give me 10 texts with random sushi name, 10 text objects with random sushi name. Actually, it's supplying the sushi name in this case. This is also kind of fun to do. File new, scripting, text editor, boom. Random sushi name. And we can say, okay, give me 1000. Okay, no, too much. Give me 108 sushi name. Right? We almost get like the matrix code happening. Modify the code, give thickness to the text object. Modify the code. It knows the previous code is generating text object, and we're gonna extrude it. Copy. So at some point you gotta slow down and look at the code, of course. Okay, this doesn't seem to extrude. Doesn't seem to extrude the text. Why? Maybe not the right way, not giving us the best code in this case. It's better that we have this text object still alive, and then we just add extrusion. So give me 25 text with random sushi name from a list, and give text thickness of 0.1. Place the text on the floor. 1, 2, 3, 4. It seems to know only 10 sushi names. Delete everything. Yeah, doesn't seem to understand how to extrude the text. So forget about that. I think that's kind of a limitation for now. So random text object with generate text object with random sushi name. This one, at least this one works. And we need to make sure we just select the script, run it. Yeah, I still want to keep this as a text object. So if we have it like 250, it can generate 250 text objects very quickly. Still, this is scripting is probably not the most efficient. It's more efficient using geometry nodes, of course. And I wonder if it can generate geometry nodes. Can you create a basic geometry nodes setup using BPY? This is going to be the test. If it's able to create geometry nodes objects, then it's going to be pretty amazing once it gets to understand geometry nodes. But we need to train the AI, of course. This one, random sushi name. We have at least 5 example Python that we can run. This is in order for you to train your brain. However, you gotta stop and then try using your brain to recreate this example, right? Yeah, with geometry nodes, I think this thing still cannot do it for us. We need, if I switch to GPT-4, to generate grid of cubes with random sizes. This should be easy if you've been using geometry nodes. Now it's gonna be using GPT-4. I don't know if this is actually working. Oh, okay. Model not found. Okay. Azure. I haven't used Azure. How about LocalAI? I guess for now, safe to say, don't go too far with this. Maybe it's not yet trained with geometry nodes. I gotta say, we did try the geometry script at some point, and it's kind of working. But this one is refused. Python error. Nodes modifier has no attribute node tree. Oh well, let's leave this at this for now. We're gonna come back to this, but I just want to show you that Obsidian with Copilot AI that's using OpenAI API, is actually really useful in order for you to understand the basic of Python in Blender. Maybe it can go to certain level and then it fails. Like in this case, it doesn't understand geometry nodes much, I want to train it using geometry script, so we can use it, you know, with geometry nodes and try to solve like simple to medium to, you know, advanced geometry nodes question. At some point we're gonna be able to do that, you know, like just source the YouTube tutorials out there and then using AI and Blender Python and geometry nodes. That's really the main idea. But for now, we're just gonna leave it here. So Copilot inside Obsidian, and then the idea is really this is the AI. It's gonna spit out like codes. Some of the codes actually works. Some of them maybe not so efficient. Some maybe fail. But this conversation can help you to train yourself with the basic of Python, you know, making it useful and fun. And you wanna try to challenge, you know, build the level of Python understanding that you can do. You know, you should be able to do this. Most of this should be pretty simple enough, you know, like random box, random grid of cubes, random sphere, stack of cylinder, random text. Just 5 basic one. I'm gonna try to think of 100, at least 100, you know, level of challenge using Blender Python. That's probably gonna be for the next video, I don't know. But we're gonna leave it there for now. Hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.